Hit record. All right, let's do square roots first.
Record.
Square, ooh, that looks a hot mess. Square roots, I'm gonna give you the general form with the variables, and then I'm gonna tell you what each one means, and then we're actually gonna graph it. You only need to graph a square root. You need 2 points. Let me show you what the graph looks like actually first. It's gonna have a starting point, and this won't be in your book or anything, that's just what I call them. This I call a start point, and then it'll have a point. I call this a direction point. Because if you put your pencil in the start and you draw towards that point, that's the direction in which it goes. Okay? So it'll look something like that. Yeah. What it is, it's really like half of a parabola, you can think about it. Like half of a parabola turned on its side. It could also then, along that same thought process, be, I'm going to call this D for direction, down like that. Depending on if that A in front is positive or negative. Okay? This is actually the inverse of a quadratic. Right? If you have y equals x squared, and you find the inverse of that, well, we cut it off, we restrict, that's why those domain restrictions were in there, because we want it to be a function when we graph the inverse. So we have to restrict that. All right. So that's what they look like. Those are the 2 points you'll need to graph them. Should we have waited on you? Okay, let me show you the equation. The equation looks like this. I noticed the same letters that keep popping up in everything I graph. Those are what? H and K, as well as the A in front. Remember what the A does? The A has the same property. Positive up, negative down. HK, this is going to be my start point. Remember I showed you that S, that start point where it starts? Okay. H, like the vertex in vertex form, yes.
Is
okay.
H the start and K is
absolutely, yep. Opposite, same. If they're missing, what are they?
0. Missing.
So if you just had the square root of x, y equals the square root of x, then h would be 0 and k would be 0. Because they're not there. All right, y'all want to graph them? These are so easy, I don't think I'm going to give you a whole step chart for it. I think we'll just graph them and it'll be easy enough for you to see.
Plot twist, we all forget how to do it on the test because we forget and then we fail the easiest part of the test. I thought this.
Here we go. First thing we want to do, well, first of all, before we actually graph it, what is A here? 1. A is in front. If A is missing, A is 1. I apologize. All right, so A is 1. So that tells me it's going to open up. Okay? What is H? Negative 1, and K is 2. So H is opposite. The original equation was x minus h, so it's got to be the opposite sign there. All right. So my start point here is that HK. Easy? Negative 1. Mark an S on it so that you know. Otherwise, you'll forget when you plot the 2 points which one you start at and which one you... I haven't found it yet. I'm facing 2. I'm facing to show you. Direction point. Just like when we had parabolas, right, in standard form, to find that easy point, we added 1 to the vertex, right? We're going to do the same thing. We're going to go over 1 from the start point. So I'm going to take that H and add 1 to it. So here, for my direction point, I'm going to be at 0. Does that make sense? Plug it in to find y, just like you did when we did quadratics. Square root of 0 plus 1 plus 2 So my direction point is 0, 3, exactly. I moved over 1 from the start point. I plugged it in my equation.
You know that A is square root of. Why do you just like get rid of the square root?
The square root of 1 is 1.
Okay.
1,000.
What's your question? No, it's okay. Ask. Okay. What's the domain?
-1, infinity.
Good job. -1. Bracket though, right? This time it's a bracket. Because, What about in the range, guys? To infinity. Good job. Remember domain, guys. Let me reel y'all back in here. Domain is left to right. Range is up and down, right?
Oh wait, domain is -1 this time?
Yes, because left to right.
I thought it always said.
This one's restricted.
It's a ray.
Because it's a ray. Looks like a ray. All right.
His name is not wrong.
Graph it. Graph it. You try the. All right. Ready? Start point here is what? 3, 0. Remember HK, so it's A square root of X minus H plus K.
So it's H and K are the 2 points.
Correct. This is S for start. Now my direction point, I need to move 1 over, so I'm going to use 4. You don't want to go to the left on this one because then that would give you a negative under the radical. 1, you add 1 to where you started.
So
You make that your
On the
X.
other side, on the negative side, your point is originally, would you pick a point to the left or right of it?
Always to the right. 4 minus 3. 4 minus 3 is 1, just like I told you it would be. 2 times 1 is 2, so you should have gotten 4, 2. Is that not what you got for your direction point?
I got 4. I got 4. How do you know it curves this way or if it just goes like straight up?
Think about a parabola on its side. Cube roots. Cube roots are almost exactly the same, but instead of just having the one piece, they have a start. They have 2 direction pieces. Because a cube root can be negative, so I can have that piece and I can have the negative portion of it. So it's going to look like that, or, and it doesn't matter which one is direction 1, which one is direction 2, they just kind of twist around. Yeah. You will notice this equation looks almost exactly the same because it is. The only difference is it's a cubed root now, and I can put a negative under a cubed root. My start point is still HK. If anything is missing in terms of H or K, it's still 0. A is missing, it's 1. A still does the same thing. If it's regular, and this would be the inverse of what function? Cube root. I mean a cubic and a cube root.
That makes this also cubic.
This is why, Drew. Because it's a cubic and a cubic is 1 to 1. Good job. So this is that was really good. I'm impressed. So this one is a function. Either way you turn it, we don't have to restrict the domain on this one. All right, let's do it. Y equals, let's do cubed root of X minus 2 plus 1. Okay. Now you have to be careful here because I do need two direction points instead of just 1. First thing I'm gonna do,
2-1.
my first two steps are gonna be exactly the same. My start point is, what'd you say, Ben?
2-1.
2, 1. 2, 1. Start. Direction 1, I'm gonna find it exactly the same way. So my X, I'm gonna take my H and add 1 to it. So what's my X? 3. Move over 1 from where you started. Okay? Plug it in. 3 minus 2 is?
1.
What is the cubed root of 1? And what is 1 plus 1? So my first direction point is 3, 2. Pretty easy so far? Because it's exactly the same, right? Here's the new part. I need another one. I bet you can guess what I need to do. Go back to that start point and go backwards. Instead of forwards, now go backwards. I need one on either side. It looks like an S, right?
Now we're subtracting.
So now for my direction 2, so this one I did start plus 1. This one I'm going to do start minus 1. Okay?
Wait, so Miss McGee, pretty much this thing was the same until you get to direction 2.
Yeah, it's exactly. You're exactly right. It is.
That one, if that was the other one, you'd be done.
Exactly. Yep. If this was a square root, I would just connect those and be done with it. Because it's a cube root, I'm going to add one more point in there because I need 3 points to do a cube root.
4
What?
points. Is there one with 4?
No. This is as far as we take it. I'm going to plug it in. Cubed root of 1 minus 2 plus 1. Here's where my change comes in. What's the cubed root of negative 1? Negative 1. And negative 1 plus 1 is, so this point is, this is D2. Does that make sense? It is the same thing, it just one to the left also. What's the domain here? Absolutely. Good job, Tyshawn. What's the range? Negative infinity, positive infinity.
Miss McGee, is that your sponsor? The mashed chicken.